Factorization. You have learned factorization. An algebraic expression is writing it as a product of its factors. We have factorized algebraic expressions by the method of common factors and by regrouping the terms. Now let us learn how to factorize algebraic expressions using identities. You have learned the following algebraic identities. Let's factorize an expression using the first identity. In this expression, the first and the last terms are perfect squares. Also, the middle term has a positive sign. If we rewrite the middle term as 2 times 4 times x, the given expression is in the same form as the right-hand side of the identity. Considering that x is the equivalent of a and 4 is the equivalent of b, we can rewrite the given expression as x added to 4 whole square. This is the required factorization. Now let's factorize the given expression. We can write 12x as 2 times 6 times x. Thus, we can rewrite the given expression as x plus 6 whole square. Now we will take the second identity and see how we use it to factorize algebraic expressions. The first and last terms are perfect squares. The middle term takes a negative sign and can be written as 2 times 5z times 2, where a equals 5 times z and b equals 2. So the expression is in the form of the second identity. Thus we can rewrite the expression as 5z minus 2 the whole square. This is the required factorization. Now, let's consider the third identity and see how we can apply it to factorize the following algebraic expression. Let's first simplify the terms. 49 times x to the power 2 as 7x whole square and 36 as 6 square. Thus we can write the expression as shown here. Considering 7x as the equivalent of a and 6 as the equivalent of b, we can rewrite the given expression using the third identity. Now, 7x added to 6 and 7x minus 6 cannot be factorized further. Thus we get the factors of the given expression. Observe the following expressions. These expressions are not of the type a plus b the whole square or a minus b the whole square. That is, they are not perfect squares. Also, these are not of the type a square minus b square. Recall the fourth identity that you have studied. Let's use the fourth identity to factorize an algebraic expression of the type x square plus px plus q, where p is the coefficient of the middle term and q is a constant. Let us factorize x square plus 5x plus 6. If we compare the RHS of identity with x square plus 5x plus 6, we get ab equal to 6 and a plus b equal to 5. From this, we can obtain A and B. The factors then will be x plus A and x plus B. If AB is equal to 6, then A and B are factors of 6, which is the coefficient of the middle term. Let us try A is equal to 6, B is equal to 1. For these values, A plus B is equal to 7 and not 5. So this choice is not right. Let us try A is equal to 2, B is equal to 3. For this we get A plus B is equal to 5 exactly as required. Thus, by taking A as 2 and B as 3, we get the factors as x plus 2 into x plus 3. Also, we can simplify as shown here. Now let us factorize y square minus 8y plus 15. Next, we choose two factors of 15 in such a way that their sum equals negative 8, which is the coefficient of x in the middle term. When the coefficient of the middle term is negative and the constant term is positive, both the factors must be negative. Thus, we write the expression as shown and then we simplify to find the factors. Let us factorize y square minus 2y minus 24. We begin by factorizing the constant term 24 in the expression so that we get two factors in each combination. Now we choose two factors of 24 in such a way that their sum equals negative 2. When the coefficient of the middle term is negative and the constant term is also negative, one of the factor is positive while the other factor is negative and the greater factor is negative. Thus, we write the expression as displayed here. Finally, we simplify to find the factors. Summary. Let us summarize what we have learned. Factorization using standard identities. A plus b the whole square is equal to a square plus 2ab plus b square. A minus b the whole square is equal to a square minus 2ab plus b square. A plus b into a minus b is equal to a square minus b square. X plus a into x plus b is equal to x square plus a plus b into x plus ab. To factorize a given expression, we check if it matches the right-hand side of the identity. The left-hand side of the matching identity gives the factorized form of the expression.